Okay, so I'm hearing some C's and some D's. Okay,
I think it's B.
and some B's.
I think it's probably gonna be A.
It's D.
No, it's D.
Wait, I didn't do 4. D.
So here's the way I would think about it.
Is it a D or B?
It says my car can get 27 miles for every gallon I put in it. And I have to travel a total of 2,727 miles. So how many gallons of gas do I need to travel 2,727 miles, given that the average it travels is 27 miles per gallon? Well, we can divide those. The number of miles we need to travel divided by the average miles per gallon. If I divide those, I get 101 gallons. So I need 101 gallons of gas. Okay? Every gallon is going to cost me $4.04. So if I'm going to buy 101 gallons at a price of $4.04, how much am I going to spend? 404 times 101 is 408.04, which is D. So here I'm asked to find the solutions. What are the solutions? Solutions, roots, x-intercepts, the zeros. Those are all the same thing. Of this quadratic equation. What's different about this quadratic equation than the ones we've been working with for the last 3 weeks?
No.
Equal sign.
So there's been equal signs in the ones before. What is our general form of a quadratic? A quadratic normally looks like right, that's what a quadratic equation is. Ax squared plus bx plus c equals 0.
So now you only have the A term, you're missing the BX.
There is no b term. There is only one x. Remember, before we've been doing these problems, they've had an x squared term and an x to the first term. Well, how can I find the solutions when I have an x squared and an x to the first? You can factor, complete the square, or the quadratic formula. You can do any of those. Here, there is no x term. There's only an x squared term. Well, how do we solve equations that only have a single x? Well, we want to get x by itself.
So you can take the square root of that.
So why is x not by itself? It's being squared. So do the opposite. The opposite of squaring x is to take a square root of x. Anything you do to one side, you have to do to the other. The square root of x squared cancels, and you're left with x. The square root of 49 is 7. Here's the one thing you have to remember. What did we do to both sides? We took a square root. Anytime I choose to take a square root, I must always account for two possibilities. Positive or negative 7. Because what number times itself is 49? Well, it could be 7 times 7. It could be negative 7 times negative 7. Both of those could work. So when I take a square root, I must account for the positive and negative possibility. Which means I have two x-intercepts. There's an x-intercept at positive 7, and there's an x-intercept at negative 7. That's it. Okay, so this is correct. We would take a square root of both sides. The square root of x squared is x. The square root of 169 is 13. And because I chose to take a square root, I have to account for the plus or minus possibility. Same kind of problem, but the a is now 7. All right, does everybody say that? A is 7. It's not 1. But how many x's are there in this problem? X's. There's one x. It's being squared, but there's one x. So if I need to solve for x, let's get x by itself. So ask ourselves a question. Why is x not by itself?
It's being multiplied by 7 and or squared.
Both. Multiplied by 7 and squared.
Wait, so which one's further?
Okay, so which one's further away? That's the way I normally tell you to do it, right? Which one's further away? Well, that's a hard one, right? They're really close to each other. I'll tell you which one's farther away. Multiplying. Because
They're both being multiplied.
well, the
One's
x
being
is
multiplied
by
itself.
so
The
the
other one-
7 is farther away in the situation. It ain't really farther away, but that's the one we have to do first.
Okay, but why?
Because the way we really do it, if you're
Wait.
simplifying an expression, we simplify expressions by using PEMDAS,
Oh, okay.
right? That's the normal rule. We would normally do parentheses first, then exponents, then multiply and divide, then add and subtract. That's simplifying an expression. Here we are solving an equation, getting x by itself. The way we do that is we go the opposite of PEMDAS. You get rid of anything being added or subtracted. There's not anything. Anything being multiplied or divided. The 7 is being multiplied. So you get rid of multiplying first. Okay? So in this problem, the 7 is what's farther away from the x. The 7 is being multiplied by x. So I can undo that by dividing by 7 on both sides. 7 divided by 7 is 1, which leaves me with x squared.
Now,
112 divided by 7
16.
is 16.
You take care of that.
Is the x by itself? No, it's being squared. How can I undo squaring a number? You take a square root of both sides.
X equals positive.
Square root of x squared is x. Square root of 16 is plus or minus 4. I chose to take a square root. I must account for the plus or the negative possibility. Which means there are two x-intercepts. They're at 4 and negative 4. So those are my solutions. So here, what am I going to get rid of first? Get rid of the multiplying by 5 by
That's what I did.
dividing by 5. So I've got x squared equals 25. Now the x is being squared, so I take a square root of both sides. Square root of x squared is x. Square root of 25 is plus or minus 5. Don't forget the equal sign. So x is equal to plus or minus 5. That means there are two x-intercepts. There's one at 5 and there's one at negative 5. What are the solutions of the equation? Negative 3x squared equals negative 24.
Same process?
Pretty much. So if I write the problem down, 3x squared equals negative 24. How many x's do I have? 1. So let's solve for it. Why is the x not by itself?
Being multiplied
It's
by
being
negative
multiplied by
3 is-
-3.
Multiplied by negative 3, and it's being squared. Which one do I get rid of first?
the negative 3.
Multiplying by negative 3. I can get rid of that by dividing by negative 3 on both sides. That may be the biggest negative I've ever drawn. Negative 3 divided by negative 3 is 1. 1 times x squared is just x squared. Now, negative 24 divided by negative 3 is positive 8. Yikes. Is the x by itself? Not yet, because it's being squared. So how can I undo squaring a number?
Take the square root.
Take a square root of both sides.
That looks like a timer thing.
The square root of x squared is x. This is what you just did of Math Excel on yesterday.
I just
Now
said
the
these.
square root of 8. So what number times itself is 8? It's not a perfect square. Can I rewrite it as a perfect square times another whole number?
Yes.
So remember, what's our perfect squares?
1.
1, 4, 9. I can stop. I've gone past 8.
Yeah.
So can I write 8 as 4 times something?
Yes.
Again, it's the same thing as 4 times 2. And the reason we do that, what is the square root of 4?
2.
The square root of 4 is 2. So that 2 will come outside the radical. What's left underneath the radical?
2.
The 2. But now, one thing I've forgotten, I chose to take a square root,
Plus or minus.
so I have to account for the plus or minus possibility. So there are 2 x-intercepts. They're at 2 radical 2 and at negative 2 radical 2.
Negative 1/2
Divide by negative 1/2, okay?
each side. And then
X squared
X
equals
squared.
72.
get 72.
Okay,
Take the square root.
Good. Lana, just take it.
okay.
No, you got it.
No, you got it. You started.
Go.
Go ahead. And then you get x equals. Hold on. X equals 74. Plus or minus the square root of 9 times 8.
Okay,
And then x equals plus or minus 3 times, no, 3 square root 3 times 8. Right? No.
no. So when you take the square root of 9,
Mhm.
because it's a perfect square, the 3 comes outside the radical. And you don't leave anything inside the radical for that number. The only number that stays in the radical is the one that you can't break out.
Break up 4. I mean 8.
Say again?
Then back by 8. Break down to 8.
Right. This is still not simplified. Okay? Because 8 will break down again. So remember, I told you if you don't, this is from Friday, if you don't pick the highest perfect square first, then you might have to simplify again. So 9 is a perfect square that works, but it's not the biggest perfect square that works.
3 times 6 is plus minus 6.
That'd be 12, wouldn't it?
Good job.
Plus or minus square. Or whatever.
4 breaks down, 8 breaks down into 2 times 4. And then
So
X
yes,
breaks
if you
down
want to,
2.
so we can keep simplifying this way, that's fine. So 8 will break down as 4 times 2. The square root of 4 is 2. So you would have 2 times 3 on the outside, and then radical 2 left on the inside. And so if you do it this way, 2 times 3 is 6. So this should be 6 radical 2. That will work. Okay? The easier way to do it, I think it's easier. Starting here, where you had x squared equals 72. You took a square root of both sides. So x equals, now 72 is not a perfect square. So now I'm going to list my perfect squares. 1, 4, 9, 16, 25, 36, 49, 64. The next one's 81. That's too big. So can I rewrite 72 as 64 times the whole number? No. Can I do 49 times the whole number? That's not going to work either. 36 times the whole number.
Yeah.
That works. 72 can be written as 36 times 2. And so now the square root of 36 is 6.
That makes sense.
So this way will work. It's just an extra step you have to do. You have to make sure what you have underneath the radical doesn't simplify again. Versus if you do it my way, if you start with the biggest and work down, you won't ever have to simplify a second time.
It's just further steps.
Okay,
Can I try?
I want to solve, which means I would like to get x by itself. How many x's are there? One x. So let's get it by itself. Why is the x not by itself?
Being
Being times
multiplied,
3 and squared.
squared, and subtracted.
That's it. 3 reasons.
Oh.
Multiplied by 3, squared, and subtracted by 5. Right? All those are on the same side. So I have to undo all of those. So which one is the farthest away from the x?
Negative 5.
The subtracting 5. So how do I get rid of subtracting 5? I would add 5 to both sides. That would cancel on the left. So I'm going to move over here. That would give me 3x squared equals 22 plus 5 is 27. Is x by itself yet? No. So what am I going to get rid of next?
Divide by 3.
I'm going to get rid of multiplying by 3 by dividing by 3 on both sides. 3 divided by 3 is 1. That leaves me with x squared. 27 divided by 3 is 9. Is the x by itself? No, it's being squared. So how can I undo squaring x? Take a square root. Square root of x squared. Those cancel. Leave me with x. The square root of 9 is
3.
plus or minus 3. Whenever I take a square root, I must account for the plus or the minus possibility. Does that give you deja vu? Hopefully. I'm going to say it enough times, maybe it will. Questions? That's the correct first step. So let's subtract 17.
192.
Okay, so you've got 3x squared equals 192. Then did you take a square root of 192? Bad. Very, very bad. Very, very bad. First, x is being multiplied by 3. So you have to divide both sides by 3. That's okay. X squared equals 64. Take a square root of both sides. Plus or minus 8. So x equals 8. X equals negative 8. What are the solutions to the equation x squared equals negative 121? How many x's do I have? 1. Okay. And it's being squared. So how can I undo squaring a number? I would take a square root of both sides. So I could take a square root and a square root. This is going to be plus or minus the square root of negative 121.
You can't get it. Not one.
Because what number times itself is a negative number? Nothing, because a negative times a negative is positive, and a positive times a positive is positive. I can't multiply the same thing by itself and get a negative answer. So if you get an error, there is no real solution. No real solution. No real solution. This means on a graph, this would not cross the x-axis.
See, I wish I would start with that first, because like, as y'all teach it, y'all make it like there's always going to be a solution. And then like, you throw this in there, and then everybody's like...
Well, there is a solution.
It's just not on the x-axis.
It's not on the x-axis, and it's not real.
So, wait, so does that mean like...
Now, let's talk about what real means. Real means it's a real number. So our real number system is all the fractions, all the decimals, all the whole numbers, negative whole numbers. Everything that you've probably done math with to this point is a real number. Pi is a real number. 3.1415, that's an irrational number.
Infinity a real number too?
Well, infinity is not any kind of number.
It's any and every number, right?
But we have another kind of number system. So let me look. People hate this. People hate this. I'm doing it anyways. I don't care. Okay. So our number system. When you first learned numbers, what did you learn? You learned your counting numbers. You didn't start with 0. You learned 1, 2, 3, 4, 5, 6. Then, so those are called the counting numbers. Then you learned about the whole numbers. That's where you added in 0. Then what did you learn about next? Well, you probably learned about fractions and stuff next. Well, that's not the actual progression. The next thing you're supposed to learn about are integers. These are whole numbers and their opposites. So integers are like -3, -5, -17. Then you learned about, these are called rational numbers. So rational numbers are fractions.
In decimals, right?
Mm-hmm. So rational numbers would be like 3/4, 1/2, -3. Okay? But then there's also this other kind of number.
Wait, why would -3 be in that?
Negative 3/4. Okay. Then we learned about the irrational numbers. These are different than rational numbers. So irrational numbers are pi, 3.1415926, which was yesterday. Happy Pi Day. Sorry you didn't get to visit here with me. Okay, but that's an irrational number. So is the square root of 3. What number times itself is 3? It's a number that goes forever. Okay, all the rational and irrational numbers together, those make up what we call the real number system.
Wait.
So all rational numbers and all irrational numbers are real. But there's another set of numbers.
It's a
Who is
big
letting
picture.
you cook?
Over here, these are called the imaginary numbers.
What? This is some dang like crazy junk.
They are named very poorly. They name them the imaginary numbers, but they exist. They really exist,
So what are they?
but they're called imaginary. So here is the imaginary number. I just told you what happens when you take the square root of a negative. What number times itself is -1? It's impossible in the real numbers. It's an imaginary number.
That's the symbol?
It's an I. It's a cursive I, lowercase, cursive lowercase I. That's the imaginary number. So, on your homework, if you get this problem, it's going to say no real solution.
There is an imaginary.
So, here's what we do. I can take a square root of both sides, right? I'm going to go quick, I know. Square root, x equals plus or minus the square root of -121. I can rewrite -121 as -1 times 121. What's the square root of 121? What number times itself is 121? It's 11. So that comes outside the radical. What's the square root of -1? The imaginary number. So x is plus or minus 11i.
That looks whack.
Because the square root of -1 is I. It's imaginary. It can't happen in the real world. Not today. Friday.
Old cherry.
Friday.
I had like a brain fog like